Okay, so we have a limit x approaching 1, and we have an expression at the bottom which will make this thing undefined. But it's not undefined, it does exist. It gives you 10. So what that means is that f at x minus 8. In here, there has to be a factor, right? A factor of x minus 1. So let me call this g at x. So I don't know if you call factor theorem. If this has a factor of x minus 1, if you plug in 1 in here, so f at 1, this has to be 0, okay, which makes f at 1 to approach 8. Okay, so the limit as x approaches to 1 has to equal to 8. Okay, if it doesn't, just think about it this way. Remember all our limit examples. If that one was approaching 0, let's say this was approaching some number L. A number divided by a really small number cannot approach a number 10. It'll be undefinedly large. The only way it could approach a particular number is if the numerator was also approaching 0. That's essentially what I'm doing here. The limit on the top, right? So I use factor theorem. I guess you could also argue, well, because the bottom is approaching 0, the top, right, also better be approaching 0. Otherwise, there's no chance of for the whole limit, the quotient of the limit to equal to 10. Okay, so we can argue that the limit of just the function itself has to be approaching 8.